Our first example in solving systems of linear equations is finding two unknown numbers. One number is 5 less than a second number. Twice the second number is 2 less than 5 times the first. Find the two numbers. So this is what we are being asked to do. Find the two numbers. And the first two sentences are direct translations. So in section 1.4, remember we had all of those different translations between English and math. So we are going to translate these two sentences into two equations with two variables for the unknown numbers. So let me just call one number x and a second number y. So then when they say second number, again, remember that's y. And first is the same as 1. So that's x. Okay. So let's start at the beginning of the first sentence. One number, which we labeled x, is, which means equals, 5 less than. Now remember, less than means subtraction, but it also changes the order. So 5 less than the second number. Then our next equation, our next sentence. Twice, that means 2 times as much. The second number, so 2y, is means equals 2 less than. So again, less than is subtracting and changing the order. 5 times the first, which is x. So that gets us our two equations and two variables relating the known, which is given, to the unknown. Now we can solve this using any of the methods, that we prefer. We can use the graphing method, but that's not very precise. So we'll stick to either substitution or addition elimination. Now in this case, we do have a great setup for substitution because x equals. This is already solved for the x variable. So let me take that and put that into the other equation instead of x, okay? So the second equation here, 2y equals 5 times x, which is y minus 5. And then minus 2 to complete that equation. Okay. So now we only have one variable. We can solve this equation for y. So the first thing we're going to have to do, we need the distributive property to remove any parentheses or grouping. So 5 times y is 5y, and 5 times negative 5 is negative 25. Everything else stays the same. So now we find that we have like terms on the right side of the equal sign. So we're going to combine those together. Negative 25 and negative 2 are the same sign. So take the sum and use the sign of the bigger number. So now we need to have the y terms on the same side. So I'm going to opposite the y term from the right side because that's where the number term is. And then we'll have 2 minus 5, which is negative 3y's on the left side. And on the right side, 0 minus 27, just negative 27. Then finally, the multiplication property. If there's a number being multiplied by our variable, we're going to multiply the reciprocal, which is the same as just dividing that factor from both sides of the equal sign so that we have just y on the left side. And that quotient is 9, same sign, so positive. Okay. So we have a particular solution here. We know y equals 9. But now we have to figure out what x is. So let's take that substituted equation here. And let's put 9 in for y. So x is 5 less than 9, which is 4. Okay, so we think we know what these numbers are. Let's see if they make sense. So let's check it out. Instead of one number or first, I'm going to say 4. And instead of second number, I'm going to say 9. Okay. So 4 is 5 less than 9. Yeah, that makes sense. That's true. In the second sentence, twice 9, so that's 18, is 2 less than 5 times 4. 2 less than 5 times 4, which is 20. So 18 is 2 less than 20? Yeah, it is. That checks out. So that means we can go ahead and state our conclusion, which is answering the question that's being asked. It says find the two numbers, right? So and these are, it's important that they're distinct numbers. So the first number is 4, because that's what X stood for. And the second number is 9, because that's what Y stood for. So that would be the conclusion or the answer to this question.